So we'll try to understand how to schedule pods to the specific nodes in this Kubernetes cluster. As we already discussed in Docker, we have a concept of labels and constraints. Here in Kubernetes, we have some basic options and also some advanced options when it comes to scheduling the pods. So by default Kubernetes scheduler will ensure that right node is selected by checking the node capacity of the CPU and RAM, and it will compare the pod resource request. By default Kubernetes scheduler will try to schedule the right node by checking the node capacity, and also it will compare it to the pod resource request, how much pod is expecting. So based on that, it will try to schedule. So Kubernetes scheduler's default behavior works well for most of the cases. In most of the cases, right, Kubernetes scheduler default behavior will work well. So it will ensure that pods are only placed on the nodes that have a sufficient resources. The default behavior, right, it will try to ensure the pods are placed on a nodes where we have a sufficient resources, and also it will try to spread the pods of the same set across the nodes. Suppose I am trying to create a replica set or stateful set. If I try to create a 3 replicas, it will try to spread across the nodes. It tries to balance the utilization of the nodes across the cluster. But in some cases, you want your pods to end up on a specific nodes. In some cases, you may have some requirement, you want to have pods to be created on a specific nodes, or you want to create a pods, you don't want to create a pods on the specific nodes. So Kubernetes have some concepts. We can inform the scheduler so that scheduler can try to schedule the node, pods on that specific nodes. We have a node selector. This is the basic scheduling feature. We have a node selector. This is a simple pod scheduling feature. This is simple pod scheduling feature that allows us to schedule pod on a specific node where labels are matching with the node selector. This is a simple pod scheduling feature that will allow scheduling pods on a specific node where node label is matching with the selector which you are trying to give. Node selector. Okay. The basic idea behind the node scheduler is it will allow pod to be scheduled on the node. Those node have a label. Like, so we can add a label to the node, and while creating a deployment, while creating a replica set, stateful set, or pod, you can give a node selector, whatever object you are trying to create, you can give a node selector. So by default, it will have some labels. You can add some other labels if required. First, let me log into the Kubernetes cluster. Let me check. Let me check here. Let me connect to the kubectl machine where I have a kubectl. These are the nodes. If you see the labels, it has some labels already. These are the labels. These are some default labels: key, value, key, value, key, value, something like this. Key and value. This is one key, this is one value. So key value pairs. It has some labels, key and value. So I can use this as a node selector, or I can add my own label, or I can add my own label. So let me add label to this worker machine. Let me add label to this worker machine. And if I select that option, node selector, then the pod will be scheduled only on that node. So we can add a label, something like this, kubectl label nodes, something like this, kubectl label nodes, your node name, whatever node, to whichever node you want to add a label, key and value. I want to give something, some key value pair. Node, just to give, I am saying node 1, something like this. This is key, this is value. Whatever you want to give, you can give something like this. Whatever name, worker 1, or whatever you want to give. Key value pair. If you want to give something like this, name, worker 1, something like this. Now if I see that label, now if you see this one, there is a label. We have added one label. Now while creating a pod or while creating whatever controller in pod manifest, you can mention this label as a node selector. Suppose I want to create, let me delete whatever I have. I will show now. Let me take whatever you want to, like Java, web app, whatever object, RC or RS or deployment. So whatever you want to do. So here under your pod specification, you can mention that node selector. Node selector. Node selector. Something like this. Something like this. Node selector. Right? Whatever you want to give. The whatever node label you have, like name equals to worker 1. So now we are creating deployment. For deployment, we are trying to create two replicas, two pods. This is our pod template. This is our pod template. Under pod spec, we are saying node selector. So I'm trying to create two replicas. Now, where these two replicas will be created? These pods, basically the two pods will be created where? Wherever we have a node select, like wherever node we have a label as this. Node label has this one. So let me show that. Kubectl apply -f Java web app deployment, whatever. Now, if you see, now pods got created. Where your pods are running, under which node it is running? Why both are running in same node? So why both are running in the same node? Because of the node selector. Because of the node selector. Now let me do this. If I scale, will it scale in a different node? I have a lot of nodes, right? Like I have another node. So if I scale also, scaling will happen in the same node. If I scale also, scaling will happen in the same node. Kubectl scale deployment. My deployment name is this hyphen replicas as 3. So because of the node selector, because of this node selector, parts are getting scheduled on the same node wherever node, like whatever node has this label. This is node selector, the basic feature. Let me delete this deployment. Now let's assume I have given a label which is not, no, I'm trying to give a node selector which is no node has this label. I'm saying something like this. Name. Just I'm giving something which is not existed. Something like this, name or type, whatever, which is not existed. Suppose I'm giving something like this. Type, something like this. None of the node has this label. None of the node has this label. So will it schedule now? So none of the node has this label. Now is it going to schedule this? I'm trying to deploy. Now if you see, it is in pending state. It is in, parts are in pending state. It is in pending state because it is in pending state because None of the nodes match that node selector. None of the nodes match that node selector. So parts will not be scheduled if the node selector, like none of the node has that label. This is one way of scheduling the nodes on a specific nodes. And there is another concept. These parts will not be scheduled unless until you have a node with that label now. So let me delete this. So there is another option called node affinity. There is a one more option called node affinity. So this is basic way of selecting the nodes. Kubernetes also offers advanced features, advanced selecting features, node affinity. As we already discussed earlier, node selector is the simplest way of pod scheduling. The node selector is the simplest way of scheduling the pods. The affinity is having some advanced features, advanced functionalities on top of node selector. As of now, that if I use node selector, it is like a hard condition. It is like a hard condition, hard scheduling rules. It is like hard scheduling rules, right? Now, if node has the label, then only it will schedule. If the node doesn't have a label, it will not schedule. But when I go for a node affinity, we can define hard rules as well as soft rules. What is hard rule? Hard rule in the sense, if the node has the label, then only it has to schedule. If the none of the node has that label, it will not schedule. That is hard rule. We can also define a soft rule, which means if the rules are not met, still I want scheduler to schedule pod. If rules are not satisfied, if the condition is not satisfied, still I want scheduler to schedule pods. So node affinity supports this. Node affinity is a way to set rules based on which the scheduler can select the nodes. So node affinity is expanding node selector feature. We are node affinity is like adding some additional feature on top of node selector. So this is again works based on the node labels. You add a labels, you use those labels in your node affinity rules. If the rule is satisfied, you can define two types of rules like hard rules and soft rules. If rule is satisfied, it can schedule. If rule is not satisfied, still we can schedule based on the node affinity condition which we are using. So if you see, there are two types of affinity rules: preferred rules, preferred rules, required rules. Preferred, soft, required, hard rules. So in a preferred rule, pod will be assigned on a non-matching node if no other node has that label. So this is preferred rule. Preferred during scheduling, ignore during execution, which means what will happen, right? Suppose I am trying to give some label as a rule. If none of the node has that label, first it will try to prefer. It will try to prefer to schedule on that node. If some node has that label, whatever I am using as a condition. Preferred during scheduling, it will prefer to schedule on that node. but none of the node has that label, it will ignore during the execution, which means if none of the node has that label, still it will schedule, it will ignore during the execution because no node has that label. Soft rule. This is soft rule. And there is one more hard rule. Required during scheduling, ignore during execution. So in this, what will happen? Pod will be scheduled only if the node label is specified. The pod will be scheduled only if the node label is specified. So if the node doesn't have this label, whatever you are selecting in the rule, it will not schedule. Required during scheduling. The node should have a label. Then only it will schedule. Ignore during execution, which means once the pod is scheduled, it will ignore the label. Suppose you deleted the label or you modified the label, pod will still continue to run on that node in this rule. It is required while during scheduling, right? Once the pod is scheduled, later if you modify the labels or if you delete the labels, pod will still continue to run on that node. This is required during scheduling and ignore during execution. So your nodes should, some of the nodes should have a label, whatever you are giving in node affinity. It will schedule only if the node has that label. Once your pod is scheduled, later it will ignore the label. Suppose your label got modified or deleted, but still the pod will continue to run on that node. Then there is another one more required rule. Required during scheduling, required during execution. Required during scheduling and required during execution, right? Pod will be scheduled only if the node label specified is matching with the labels of the node. And later, if I remove the label from the node or if I updated my node label, what will happen to the pods if the pod has this affinity rule? Suppose while defining a pod, I am using node affinity and this is my rule. It will be scheduled only if the node labels are specified in the pod is matching with the labels of the node. Then only it will schedule. Once it is scheduled, if your node labels got updated or removed, what will happen to the pods? Whatever pod has this affinity rule. If the node labels change in the future, what will happen? If this is my rule, if the node labels are changing in the future, what will happen? The pods will be evicted. It means it will be removed. It will be removed. So these are having some advanced features. Node affinity is having some advanced features. You can define this affinity rule something like this. Required during scheduling, ignore during execution. Is it a soft rule or hard rule? Required during scheduling, ignore during execution. Is it a soft rule or hard rule? Hard rule. And again, it is required during scheduling, but once the parts are scheduled, if I updated my node labels, will those parts will be removed or it will be still continue to run? ignored during execution. It will continue to run if you modify the label or delete the node label. But if I use this one, required during scheduling and required during execution, it will be scheduled only if it is again hard rule. But what will happen if I modify the labels once it is scheduled? What will happen to those pods? If the labels change in the future, the pod will be evicted. Evicted in the sense it will be removed from that node. So this is node affinity. So you can use this rule in your YML also. Something like this. Let me show that. Now let me modify this. Let me modify this. Now, instead of giving something like this node selector, instead of giving something like this node selector, I can give something like this affinity. Node affinity. Something like this. Something like this. Name. We can use some advanced features here. Again, match expressions, right? We can use in, not in, here, in, not in. Like this is your node label. This is your node label value. Node label key and value. So something like this. You can pass, if you want to pass multiple values, you can pass multiple values also. In, not in, some advanced features. Instead of node selector, we are using affinity. Node affinity. So now let's try. Let's try to kubectl apply -f Java web app deployment .yml. Let me do the dry run. You may have some syntax issues. Case unknown field node selector terms. So the placement is matters. Yeah. Now, if you see, I have these labels. This node has that label. Name equals to worker 1. Name equals to worker 1. And when I am deploying some application, now I am using affinity, node affinity. Required during scheduling, ignore during execution. Hard limit, hard, basically hard rule. So node label key and value should be this. Value should be this. kubectl apply -f Java web app deployment.yml. Why it is in pending state, guys? Why it is in pending state? I have a node with this key and this. I have a node which has a label as this, value as this. But why it is still in pending? It's case sensitive. If you see, it's case sensitive. If you see, it's case sensitive. My node label, if you see the node label, worker1 small, in my pod affinity rule, this is caps, right? So let me change. Now let me now it is got scheduled. Now if you see these pods, now I updated my deployment with that node affinity rules. Now it is running here. This is required during scheduling and ignored during execution. Required during scheduling and ignored during execution. Node affinity rule. Now it will ignore once it has been scheduled. Suppose I modify the label now. I modify the label now, right? It will ignore. Suppose if I modify my label like worker, something like this. Now your node label got modified. Your node label got modified. Your node label got modified, and your pods are still running. kubectl describe pod. If you see here, your pod you can see in a YML. If it is not showing here, let me show that in a YML format. kubectl get pod -o YAML. You can see that in a YML format. Now here, do you see the tolerations? Sorry, this is not I'm talking about. Here, affinity. If you see the affinity, now it is worker 1. Our pod has a affinity rule as worker 1, but the label got modified, but still it is running because required during scheduling and ignored during execution. This is the affinity rule. So it is ignored. This is hard limit, right? This is hard limit. And there is a soft limit. There is a soft limit. There is a soft limit. then it will not go to that node. Now let me, that you can explore guys. At once you are familiar with this topic, or let me show you. Now it will not schedule because we are trying to schedule again, right? It will be in pending state because now this node affinity is different and actually node label is different. So it will not schedule. If you one pod got deleted, again next pod will not be scheduled because it will try to schedule again, right? So it will not schedule if your label got modified. Once you schedule, if you modify your label, again it will not schedule. So this is hard limit. Now I want to have a soft limit. I mean to say soft limit in the sense it has to prefer, it has to prefer, but if none of the node has that label, still I want to schedule my pods. None of the labels have that, none of the node has that label, still I want to schedule. In that case, I can use other option. Something like this. Preferred during scheduling, ignore during execution. Preferred during scheduling, ignore during execution. I can use this rule. Something like this. Instead of that required, right? I can have something like this. That rule will be changed. Something like this. Suppose even though, now let me give node values, I can say like, guys, this is also same, this is also same. Here, whatever we have given earlier, that is also same, or we can give something like this. Name, worker 1. Now even though it's not there, none of the node has this label, right? Still it will be scheduled because of this, right? Let me validate first the YML. Line number 24, there is an issue. Something like this. Now if you see, none of the node has that label. I have something like this. I have something like this. But here, now I am trying to use something like this, but none of the node has. But my affinity rule is preferred during scheduling, ignore during execution, which means I am preferring. If it has, it will deploy. Otherwise, it will deploy in a different node or whatever node. If you see, parts are running. Parts are running, even though none of the node has that label, because we have a soft condition preferred during scheduling, ignore during execution. Prefer during scheduling and ignore during execution. I'm preferring if you have a node with that label, deploy. Otherwise, still I want my pods to be run somewhere. So this is another node affinity. So we have this advanced option to schedule the pods on a specific nodes. Node affinity, node selector. Then there is a one more concept called taints. There is a one more concept called taints. So taints, taint is a property of a node that allows you to repel in the sense it will not schedule to that nodes. It is like a reverse. Taint is a property of a node that allows you to repel a set of pods unless until those pods explicitly tolerates the taint. So we can taint a node. We can taint a node. If your pod is not tolerating the taint, your pods will not be scheduled in that node. It is like you are draining. It's kind of a anti-affinity. It's kind of a taint is like a anti-affinity. You are tainting a node, your pods will not be scheduled unless until your pod tolerates the taint. If you see why master, why our pods are not scheduling to a master machine. If you see, I have a master. As of now, whatever pods we are, so far whatever pods we have created, why our pods are not scheduled to the master? Whatever pods we created so far from day one in Kubernetes cluster, why pods are not scheduled to the master? If you see, if you describe the node, master node, kubectl, describe node, your master node, do you see taint, taints? This node has a taint. This is key, this is effect, key and effect, key colon effect. So unless until your pod tolerates this taint, the pods will not be scheduled. In our pod specification, if you tolerate this taint, then only pods will be scheduled in this node. Otherwise, it will not schedule. Otherwise, it will not schedule. Right? So you can taint a node so that none of the pods will be scheduled in that node unless until your pod has to tolerate that one. I can taint some node something like this, whatever you want to give, key and value. This is key, sorry, this is effect. This is key, this is key. This one is a key. I can give whatever I want to give. This one is a key. Whatever I want to give, I can give. Value is this. This is effect. So already master node has a taint something like this. Already master node has a taint something like this. This one has no, effect is no schedule. So we can taint a node. We can taint a node, and these are the effects we can give: schedule, no execute, prefer no schedule, right? So Kubernetes scheduler will not schedule the pods without matching the toleration. Suppose if your pod has tolerating this, then only it will schedule. Otherwise, it will not schedule. Like a hard limit again, right? So no execute. No execute in the sense, suppose if my pod doesn't tolerate this effect. Suppose if my pod doesn't tolerate this effect, the pods will be removed from that node. Whatever node has this taint with this effect, if my pod doesn't tolerate this one, pods will be removed. Right? So taint is basically a property to the node. You can taint a node. Then what is toleration? Taint, we are just tainting some node, key and effect. What is tolerations, right? So if you want to deploy your pods, right? Unless until your pod tolerates the taint, it will not be scheduled. Unless until your pod tolerates the taint, it will not be scheduled. If you see, the master node already has a taint. The master node already has a taint. So whatever pods tolerates this one, those pods only will be deployed in that node. If you see kubectl get pods -o wide -n kube system, some pods are running in master node. This one, right? These are static pods. You can ignore. Static pods is running in the master. You can ignore. But this is not a static pod, but still the pod is running in the master. The pod is running in the master. And you can see this pod also is running in the master. If you describe the pod, you will come to know. This is in kube system namespace. Do you see it's tolerating? Do you see it's tolerating? Right? So it's tolerating the taint. So if your pod is tolerating, so it will schedule. Otherwise, it will not schedule. Your pod has a tolerations. It is tolerating that. If you see, your pod has toleration. Even though the effect is no schedule, still I want to schedule, right? So this is tolerating, that's why it is getting scheduled. So if you see other pod, core DNS pod also, this pod which is running, it is tolerating the taint. It is tolerating the taint. If you see, it is tolerating the taint, something like this. Now, if my pod tolerates this one, right? then only it will be scheduled. Otherwise, it will not be scheduled. I can give my own taint, something like this. Your node has a taint, your node has a taint, and if your pod tolerates your taint, then only it will be scheduled, something like this, tolerations, something like this. These are the tolerations. Your pod has to tolerate, then only it will be scheduled, and your node has a taint. If you describe your node has a taint. As of now, my master node only has a taint. kubectl describe nodes. I am describing all the nodes. If you see, as of now, only master node has a taint. I am describing all the nodes. I have not given specific node. So I am describing all the nodes. As of now, master has the taint. Now if you see, master has this taint. So if my parts doesn't tolerate this one, if my part doesn't tolerate this one, parts will not be scheduled. In my part, I have to tolerate something like this. Uh, In my part, I have to tolerate something like this. No schedule, right? If you see effect is this is the key. Then only parts will be tolerated, right? So node selector, you are selecting affinity, you are selecting which node you want to deploy. In taint, it's opposite. It's opposite. You have tainted some node, so parts will not be scheduled to that node. You parts will not be scheduled to that node unless until your pod tolerates that one. You are saying that node, I don't want to schedule any parts to that node. Your parts will not be scheduled unless until your pod tolerates that taint. It is other way around. So now if I want some parts to be deployed in my master, I have to have this something like this. So let me show that. Let me show that. So now tolerations, right? I have to tolerate that one, then only it will be deployed. Otherwise, it will not deploy. Now I want some part to be deployed in the master. Like my part should be also running in the master. It is not like I want to deploy, right? The parts also should be running in the master. Now I can use something like this. I have to tolerate tolerations. I have to tolerate tolerations, something like this. Under your spec, it has to tolerate. You are not selecting the node. You are not selecting the node as of now. You are not selecting the node. So even though your node has a taint, this part is tolerating. So parts can be scheduled in the master also. The pods can be scheduled in the master also. Now if you see, let me create only one replica. Let's see where it will schedule now. Let me delete whatever I have so that you can see where exactly it is running. Now let me do the dry run. I'll try to validate. So now let me deploy. Now let's see where and all it is running. I have only one replica. Container is getting created. So where it is getting created, let's see. Now if you see, it is getting scheduled in the master. kubectl get nodes in the master. How come it is able to schedule in the master? As of now, none of the parts were able to schedule in the master, because we are tolerating that one. Now let me try to scale deployment, my deployment name, hyphen replicas as 2. Now it is scheduling in another node also. It is not like you are selecting taints and tolerations. It is not like you are selecting the node. Your node has some taint, but still you want to schedule. We are not selecting the taint here. So your node has a taint, but I am tolerating so that parts can come in that node also. Now if you scale up, it's scheduling in another node also. It is not selecting the taint. We are tolerating the taint. I know my node has some taint. Still I want to deploy, I can tolerate. Now if you see, if I scale up, it scale up. My parts are getting created across the servers, but this node doesn't have any taint. This node doesn't have any taint. Your node has a taint, you are tolerating so that your part can be scheduled, can be. It is not like it will be, can be scheduled on that node also. So that is how taints and tolerations works. If I want to taint, I can taint, right, on my own. I can taint something like this. kubectl taint nodes, something like this. Now, if I taint my node with this effect, what will happen, guys? Suppose if I taint some node with this effect, what will happen? What will happen to the running pods if that pod doesn't tolerate this one? Suppose if I taint some node with this effect, no execute. What will happen to the pods which are already running? It will delete all those pods from that node. It will evict. I can taint something like this. Let me show something like this now. I am saying I hate pods. Now, whatever pods doesn't tolerate this one, I will say no execute. I am saying no execute. Instead of no schedule, I am saying no execute. I am tainting this one, a node This one 142. No execute. Now, right? Whatever pods that doesn't tolerate. Now, if you see why this pod earlier, this pod was running in 142. Now, why it is not running? Why it is not running in 142? Because my pod doesn't tolerating this one. My pod doesn't tolerating this one. All the pods, whatever pods which doesn't tolerate this taint will be removed, right? So these are the taints and effect. No schedule, no execute. If I have a no schedule, unless until my pod tolerates this taint, my pod will not be scheduled. If I say no execute, which means unless until your pods are tolerating this one, it will be scheduled. Otherwise, it will be running. Otherwise, all the pods which doesn't tolerate this one, this effect, it will be deleted. So this is how you can use taints and tolerations. Now let me update my deployment. Let me delete. Now here, now I have a node with, I want to tolerate that one also. Now, no execute, no execute. And the keys, I want to tolerate that one also. The keys, whatever I have given, I think key is this, I hate nodes. I hate pods, right? So now, if you see the taint, kubectl get nodes or kubectl describe nodes, grep. If you see this one, hate pods, one of the node has this taint. Unless until my pod tolerates that one, now my pod is tolerating that one effect. This is the effect key. So unless until my pod tolerates that one, it will not be, it will be scheduled and also it will be running. Now let me apply this. So it is running in 78. Which node I have tainted? 142, right? So now let me scale up. Let me scale up my pods. kubectl scale deployment. My deployment name is Java Web App hyphen hyphen replicas like 2. Let me scale up 3. So I think I have to give a key also. I missed to give a key and value, something like this. I have to tolerate key, value. I have given wrong, guys. I have given key and value. I have given wrong. So let me update this. Let me delete this. Value is optional. Let me update my YML. This is value. Key is this. Now let me apply. Now if you see, my pod is tolerating that one. My pod is tolerating that one. It is running. Now let me scale. So it is scaling in other nodes also. But since my pod is tolerating the taint, whatever node has tainted, the pod is still running in that node. So taints are other way around. Like you can taint a node unless until your pod tolerates that, your pod will not be scheduled in that node. So this is how you can use options to schedule your pods on a specific nodes, or you can repel. You can repel in the sense you can evict pods from some nodes by tainting the nodes. These are the scheduling options we have. So now let's try to understand another concept, service of type load balancer. Service of type load balancer. So as of now, what type of services we have created, guys? What type of services we have created so far? So far we used node port, cluster IP. So if I want to access from outside, how we are accessing as of now? From outside our application, node port. What is node IP here? Your Kubernetes server IP, master or worker. Worker also it will work, guys. Not only master, any machine, node, it can be a master or it can be a worker, right? We are able to access using any IP, not only master, right? Because when we create a service of type node port, in each and every node, the port will be opened, the port will be listening. So we saw when we created a service of type node port. Now, in real time, do you see anywhere, like any application, are you accessing something like this IP address and port? Let me deploy one application. Let me deploy some application. Let me create a service for this. Let me also create a service for this. You can give something like this also. Order doesn't matter, guys. You can define kind API version next. Metadata, name, your service name, spec, selector, whatever pod label. Then ports, your port service port, target port. Optionally, I can mention a node port. If I don't mention, it will assign in some range, node port range. Then what type of service you want to create? I want to create a node port service. Optionally, I can mention node port also, something like this, whatever available in 30,000, that range. Otherwise, Kubernetes will only assign. Now let me apply this one. Whatever I have, I will delete. Now let me apply. Now my parts are running. There is a service. So I can access this application using my node IP. Node IP can be anything. Node IP can be your master or your worker, one worker to wherever, whatever it is, right? I am using public IP of this machine. And that node port, what is that node port? 32561. And inside that I have my application. So I am able to access application from outside. But in real time, do we access something like this anywhere? Any application, did you see something like this? Accessing this application, right? IP address and port, right? So we will not use IPs. Instead of IP address, we are going to use domain name, DNS concept, domain name. So in DNS servers, right, we can something like this. I can have one domain that I can map with some IP address, my IP address, so that I can access using domain name. But what about the port, right? So what is the node port range? It is in 30,000, right? So basically our applications, whenever we access, right, in a browser, what are the default ports? For HTTP, what is the default port? For HTTPS, what is the default port? For HTTP, it is 80. This is 443. So in real time, right, you will not access using IP address and ports. You need a domain name. And again, what is the default range of your node port? It is like 30,000. We cannot map with this 80 and 80. 30,000 to 32,767. And also we will not expose our Kubernetes servers to the internet. Suppose if I want to map my domain with my Kubernetes machines, my Kubernetes machine should have an internet connectivity. My Kubernetes machine should have a public IP. In real time, we will not have our applications. We will not run our Kubernetes servers on a public network for a security purpose. And also, I will keep on getting, I will keep adding my nodes, master, worker nodes will get created or removed. So each time if the IPs are getting changed, you need to update your DNS, right? So in real time, we will not use node port directly. We will not use node port directly. In real time, we will use a load balancer in between the end user and a Kubernetes cluster. So this is my Kubernetes cluster. This is my Kubernetes cluster. I have a masters, I have a workers, I have a worker. Right? In real time, there will be a load balancer in front of your Kubernetes cluster. Load balancer. Now, the end user request will go via load balancer. The end user request will go via load balancer. So this load balancer will have some IP. Just to give an example, I'm trying to put some IP, something like this. This is the load balancer IP. In DNS servers, domain name service. Our domain, let's assume this is my domain, Mithun Tech DevOps.co.in. Let's assume this is your domain. This domain is mapped with this load balancer IP. Now, whenever we access any application in our browser, first request goes to which one, guys? From our laptop. Suppose I am accessing something like this. When I am accessing something like this, flipkart.com, facebook.com. So request goes to DNS server. Request goes to DNS server. If you see, whenever you connect to internet, ISP, each internet will have some ISP, internet service provider. The service provider, your internet is configured with the DNS servers. If you see, I connected to some internet, some network. If I go and check the network, if you see, the DNS servers are configured for this ISP. These are my DNS servers for this internet provider. So these DNS servers we will not own. We are not managing DNS servers, the ISP, internet service provider. So our domain have an entry in these DNS servers. Our domain has an entry in these DNS servers. So first request goes to DNS. First request goes to DNS from our laptop, right? End user device, whether it's a laptop or mobile. First request goes to DNS. DNS lookup will happen. It will resolve the IP address. It will resolve the IP address of that domain. That IP is not your actual application server or Kubernetes server IP. That is the load balancer IP. This IP. Request comes to this one. If your application is HTTP, or if your application is HTTPS enabled, request comes to this on which port? Request comes to this on which port? You no need to specify the port number. Request comes to this one on port 80 and port 443. Is our application running in the load balancer? Is our application running in the load balancer? Where is our application? Our applications are running in our application servers. These can be normal Tomcat servers. These can be Kubernetes servers. These can be Docker servers. So the load balancer will route the traffic to this one. If it is a Kubernetes machine, you have to have a rules, details here. Your node IP and your node port, on which port your service is running. The load balancer will route the traffic on node IP and node port. If required, you can define master machine IP also in your load balancing rules. Then this guy will route the traffic to that kube proxy service, node port service, from service to pods, from service to pods, from service to pods. So your service also acting as a load balancer, but that is internal load balancer, like within the cluster. Your service, right, that virtual IP, something like this. Request goes to service, service to pods. Now we need a load balancer service, external. This is external load balancer. This service is within the Kubernetes cluster. One pod can communicate with another pod using service. Now, in real time, you need an external load balancer. But the bare metal Kubernetes clusters, like self-managed Kubernetes clusters, we don't have a support to create a service of type load balancer. I need some load balancer. But if I go for a EKS, if I go for a AKS or GKE, the cloud managed, right? Or if I create a Kubernetes cluster using KOPS, when I create a service of type load balancer, I will get an external load balancer. In case of EKS, what is the load balancer in AWS? What service? What it will create in the background? What it will create in the background? It will create a ELB. The Kubernetes have the controller, the cloud controller has access to create a load balancer, all the routing rules, right? So in a self-managed Kubernetes cluster, we cannot create a service of type load balancer. You need to manage the load balancer yourself. You need to manually create a load balancer server, install HTTPD or HA proxy, define all your routing rules. You have to do yourself, self-managed. So this is self-managed. Now, I cannot create service of type load balancer. We are not going to get a load balancer. If I say instead of node port, if I say load balancer, -f Java Web App deployment. Now, if you see, external IP, that means load balancer. So it is not able to create a load balancer. This is self-managed Kubernetes cluster. You will not get a load balancer, right? So you have to create yourself, you have to manage everything. Now, if I go for a EKS, if I go for a COPS, or if I go for a GKE, Cloud Managed Kubernetes Clusters, there is a support for your load balancer, service of type load balancer. You just create a service of type load balancer will be created, right? And also the rules, the server, your Kubernetes server details, target groups also will be reflected there. Everything will be taken care. So if I go for a managed Kubernetes cluster, I can create a service of type load balancer. In self-managed, you need to create yourself manually, define your proxy rules in your load balancer. So tomorrow we'll try to set up, I'll try to set up a EKS Kubernetes cluster. We'll set up EKS Kubernetes cluster and we will see service of type load balancer. Then we will see what is ingress, right? We'll continue tomorrow on these topics. Okay, guys, whether it's a self-managed or cloud managed, there is no difference in whatever we discussed so far. There is no difference whether it's a self-managed Kubernetes cluster or cloud managed Kubernetes cluster. It doesn't matter. Whatever we discuss, like pods, services, replica sets, daemon sets, node selector, node affinity, there is no change in the Kubernetes concept. If I go for a managed Kubernetes cluster, I have a support with external services like load balancers, right? All other Kubernetes concepts remain same. So tomorrow we will see how to set up a EKS Kubernetes cluster. And also there is a video in our YouTube channel, how to set up a Kubernetes cluster using COPS. Try to go through that video. We are not going to set up that cluster. But if you want to practice, you can set up a Kubernetes cluster using COPS. There is a video here, Kubernetes setup in AWS using COPS. And also there is a video on Kubernetes ingress controller. Try to go through these two videos. If you have a time. Tomorrow, I will set up a Kubernetes cluster using EKS, not the COPS. Okay. But Kubernetes concept remains same, guys. There is no change, right? Whether you use EKS, whether you use COPS or GKE, there is no change in the Kubernetes concept. Only the way we are setting up the cluster is getting changed. And if I use managed Kubernetes clusters, I can integrate Kubernetes with external services like load balancers, ELB. And I can use EBS provisioner. So we'll continue tomorrow, guys.